Hello everyone, this is Tarun and I'll be sharing how we modernized a legacy fixed income index system using cloud native platform engineering. This was a major transformation effort that addressed both technical and organizational challenges. I'll walk you through the challenges we faced, the modernization strategy, the technical architecture, the results we achieved, and finally the lessons we learned. By the end, I hope you will see how cloud native engineering can unlock real performance and agility in a heavily regulated financial environment. Here is the roadmap for the presentation. We will start with the legacy system challenges that forced us to rethink our approach. Then we will go into the modernization strategy we adopted, followed by the technical architecture we built. I'll then share the implementation journey and results, and wrap up with lessons learned and future directions. Let's start with the problems we were trying to solve. Our legacy fixed income index system had grown increasingly fragile. For example, monthly index rebalancing required longer maintenance windows. During that time, clients could not access critical data, which directly impacted SLS. At the same time, data volumes grew 5 times in just 3 years. The system simply couldn't process that influx efficiently. Index calculations often took 30 minutes or more during peak times, which is unacceptable when clients needed near real-time results. Finally, scalability was a huge limitation. The monolithic system couldn't handle sudden spikes in demand, such as quarter-end reporting or market volatility events. This wasn't just an IT problem. It directly affected client satisfaction, SLS, and even revenue opportunities. Clearly, something had to change. We needed a strategy that didn't just patch problems, but reimagined the whole foundation. To solve this, we adopted a platform engineering approach. That meant building a foundation that supported both stability and innovation. We could not afford outages, so we moved step by step with zero downtime goals. Infrastructure as code has ensured every environment is consistent, automated, and auditable. We applied driven design. For example, pricing logic became its own service, decoupled from reporting. CI/CD pipelines. We introduced automated pipelines. So code changes went from weeks of manual promotion to hours. For instance, we used Docker to containerize every component, making it portable and easier to scale. We redesigned workflows to be asynchronous, which prevented bottlenecks. And security compliance was integrated directly into the deployment process. So previously, we had a giant monolith, one code base, manually deployed, scaling by buying bigger boxes, and running nightly batches. Now, we run domain-bounded microservices deployed with GitOps, event-driven architecture, multi-region redundancy, and auto-scaling in Kubernetes. Think of it like moving from a single massive mainframe to an ecosystem of small, specialized teams of workers who can scale up or down instantly. This was not just a technology upgrade. It fundamentally changed how we could deliver features and respond to client needs. Let's break down what those components look like. Kubernetes and Airflow implementation. Alongside Kubernetes, we introduced Apache Airflow as our workflow orchestrator. While Kubernetes handled infrastructure scaling, Airflow gave us a framework to manage the sequence of steps in index calculation. We built containerized adapters to connect to multiple data providers because they were stateless, we could scale them independently. Airflow triggered tasks to pull issuer and bond metadata from multiple providers. Next tasks collected real-time and end-of-day bond prices, ensuring data quality checks before proceeding. Calculation engine ports spun up based on workload. For example, at month-end, the system auto-scaled to 30 ports for calculations, then scaled down overnight. For persistence, we chose time series databases that were optimized for financial tick data and are critical for both accuracy and performance. The API layer included both REST and GraphQL, supporting both diverse clients. Compliance checks like masking restricted securities happened directly at the API. Service mesh gave us fine-grained traffic control, encryption, and observability. If one service failed, we could trace exactly where and why. Airflow orchestrated the workflow end-to-end, starting from ingesting reference data and prices, and validate quality, followed by triggering calculations on Kubernetes pods. As a third step, generating reports and validations, lastly publishing to APIs and downstream customers. The entire orchestration was done by Airflow. Airflow gave us a DAG view. Every step was visible and auditable. Using these directed acyclic graphs, let's say if pricing data failed, calculations paused automatically until corrected. Think of Kubernetes as the engine and Airflow as the conductor, making sure the orchestra plays in the right order. Together, these components formed a resilient and flexible backbone server system. Critical system components. Kafka decoupled processing. Instead of requests piling up in a queue, Kafka smoothened our spikes and preserved state if one node failed. During one stress test, Kafka handled 3 times expected peak loads without dropping a message. With Redis, we cut database reads by 90%. That meant sub-millisecond access to frequently used data with cross-region replication for resilience. Kubernetes features like stateful sets for order deployment, network policies for regulatory boundaries, and horizontal pod autoscaling for elasticity have been implemented here. For example, during volatile market days, the system automatically scaled to handle 20 times more concurrent calculations without service degradation. Let's jump out to the performance improvements. We saw an 88% reduction in calculation time. What used to take 30 minutes now takes under 5. Scheduled downtime was eliminated. Clients could access the system continuously even during rebalancing. And we could now support 20 times more concurrent calculations, directly improving client SLAs. Added with Airflow orchestration, which not only did calculations run faster, but the entire workflow pipeline from ingestion to publication became more reliable and auditable. These weren't just technical wins. They directly improved the client SLAs, even reduced operational risk, and gave product teams the ability to launch indexes that weren't even possible before. The migration approach was executed in 4 phases. As a phase 1, we set up cloud infrastructure with compliance baked in, infrastructure as a code, CI/CD, and monitoring. As phase 2, we migrated historical data. We used dual write patterns and built a data validation framework. Every bond reference data and prices were checked across old and new systems before going live. As part of phase 3, we decomposed the monolith, extracting services gradually using the strangler pattern. We peeled services off one by one, running both in parallel until they are stable. When we decomposed services, Airflow became the glue between old and new systems. For example, the reference data was still in legacy database while calculations moved to Kubernetes. Airflow orchestrated across both worlds during this transition, which actually let us migrate step by step without breaking workflows. As the last phase, we cut over with blue-green deployments, ran systems in parallel, and only decommissioned legacy after full confidence. At every stage, we made sure business operations were not stopped. The key was that clients never saw disruption. For them, the system just got faster and more reliable. Technology transformation was only half the story here. We also had to transform the organization. We created a dedicated platform team that functioned as an internal service provider. We invested in developer experience, building self-service portals that standardized container environments. Stopped waiting weeks for servers. Developers had a self-service portal. Needed a database? Just one click. Needed a dev environment? Done in minutes. We ran internal tech talks, paid developers with platform engineers, and creative runbooks so teams were not dependent on specialists. Without these cultural and organizational changes, the technical success would not have been sustainable. Key takeaways. Performance transformation was the major key here. Overall, we are 8 times faster. We are doing eight times faster calculations with no downtime. We improved clients' trust and enabled entirely new products. By automating compliance in CI/CD, we reduced audit stress while deploying more frequently. We cut time to market for custom products by 70%, allowing teams to focus on innovation instead of firefighting infrastructure. As the next steps, we are now exploring machine learning for anomaly detection in market data to catch issues before they impact checks. For example, if a bond price suddenly spikes out of historical range, machine learning can flag it before impacting calculations. We are considering multi-cloud deployment strategies for resilience against provider outages. That is critical for regulated markets. We are enhancing self-service capabilities so business users can request infrastructure directly. The goal is that a business analyst can spin up a test index environment without calling the application team. We are also looking at extending Airflow DAGs to support streaming workflows. For example, triggering intraday recalculations when new market data crosses a threshold. The journey is ongoing, but the foundation we have built sets up for continuous innovation. This modernization was as much about people and process as it was about technology. It showed that with the right foundation, even legacy financial systems can be reimagined. Thank you for your time. I look forward to collaborating on building the next wave of resilient and scalable financial platforms.